Hi, and welcome back to Geology. This is Miss Sparks, and we are talking geologic time today. And so, with that being said, this is in our History of the Earth unit. And so far, we've talked about two different ways in which we can look and assign an age to a rock. The first one is our relative age, which is just a sequencing of events for us to be able to look at a section of rocks, maybe in a mountain or a area that has been exposed to a road being made or whatever it may be, and we can look at them and apply the law of superposition, which just states that older rocks are found on the bottom and younger rocks are found on the top. And then there are some geologic activities that can alter those a little bit, such as cross-cutting, which has to do with igneous intrusion, disconformities, which has to do with erosional processes, and then even a fault that can offset those rocks. So just by looking at an area, we can kind of assume what is happening. We can also use the process of absolute dating, which we talked about radioactive decay, and that process of some elements act as natural clocks and can, for lack of better terms, kind of break down over time from its original element and decay down into a different decayed element or a daughter element. You might remember we talked about parent element being the original and then decaying down into a daughter element. And so with that being said, there are different sequencing of events that we can take a look at throughout the Earth's history and kind of piece things together. And that's called geologic time. And I want you to understand that this is a really, really slow process, and that where we are as humans, we've kind of just been on the Earth for like almost a millisecond if we were thinking about the grand scheme of things. And so as we move through these next couple of days processing the eons and periods and all these different ways we can look at geologic time, I want you to think this is a very, very long, slow process. And so everything that we've kind of talked about will kind of come forth as we introduce these different almost environments that were present in certain points of Earth's history, and how we can relate that to what types of species were there and what happened to cause an extinction. Everyone goes right to the big extinction of dinosaurs, but actually there are several other ones that are even more significant than the dinosaur extinction. It just didn't kill off huge reptiles, so it doesn't get as much glory as the Triassic and Jurassic era. So with that being said, please do get out a sheet of paper and a pencil, and we are going to start taking some notes. So you're going to get very used to looking at this scale to our left here. This is called the geologic time scale. And we've separated it, or scientists have separated it, I didn't help with it, into different types of, you can see it starts with eras. There are three different types of eras: our Paleozoic, our Mesozoic, and then our Cenozoic, which we are currently in as we are talking. So geologic time has been separated and arranged in order based on relative age of rocks. So we're kind of looking back to that relative age, and we're using fossils to help us identify those different time frames. So you might remember we talked about index fossils and the process that it is a very unique fossil that only might have shown up during a certain time. And that's what we're going to be looking at, is that there's certain types of fossils that are tall tale signs that this is a certain era that we are looking at. And once again, there are three eras: Cenozoic, Mesozoic, and Paleozoic. And I should have read that the other way, because we always start from the bottom up. We will mostly spend time talking about our periods, which starts with the Precambrian, It moves all the way up to the Quaternary, which is the most recent. And you've heard me say it before, is that Cincinnati and northern Kentucky and Indiana, we have a huge amount of Ordovician era type rocks exposed. So small creatures. There's our trilobite that can be found, and we can actually even see a lot of this horn coral and fossils. And then another one that is really known in this area is this little gem right here. It's called a crinoid, which is actually kind of like seaweed of ancient times. And when you look at rocks around our area, you can normally see their stems. They were broken up during the process of fossilization. I always think they look like little Cheerios in the rocks around us, little white Cheerios. So as you can see, we are exposed in this area mostly to Paleozoic, so this older area. We're not going to find a whole lot of dinosaur bones and stuff. And there's another one that we see a lot of times. It's our brachiopod, which is just an ancient clam. So we are going to once again kind of divide into a couple of different things. We've got our eras, our periods, and our epochs. Once again, I'm mostly probably going to spend time talking about the eras and our periods, but you will hear me talk about the epochs and eons just a little bit too. So our first one is our largest unit of geologic time is our eons, and so that is divided into 4 different sections: the Hadean, the Archean, the Proterozoic, and the Phanerozoic. That's our most recent. We are mostly going to talk though about our eras, which is over here. So you are going to want to really familiarize yourself, and you will by the end of this week, the terms of Paleozoic, Mesozoic, and Cenozoic, which are smaller units that kind of help us divide into the time. So after the Precambrian, the Phanerozoic era is divided into 3. So that's what we're going to talk about. We're in this Phanerozoic kind of type of era. These are like older Precambrian, no life was there. This is kind of where you might hear of like, and we'll kind of get through part of it, is that like the earth goes through just like huge forming process of cooling, and then it becomes almost like a water world, and then it becomes a huge snowball. So it's like these Hadean, Archean, and Proterozoic are really unstable times of earth. And then it kind of like the dust settles, everything clears, and it kind of brings in this era of life. Like everything just kind of Hakuna Matata, just like settles down and forms into these 3 eras, starting with the Paleozoic, and then Mesozoic. I always think the middle for Meso, and then Cenozoic. Cena is like we're in our most current centuries, and Paleo, I think paleontology, like old. We are going to divide those eons into our periods, and I'll show you a really easy way to kind of keep them all memorized. And you're probably like, well, Ms. Sparks, you have studied this for years and years and years, where I'm just learning it, but I promise you there is a really easy cheat sheet to kind of remember them. So periods are eras that are divided into shorter times, and they are characterized by that index fossil, that fossil that I was talking about. So a trilobite is a good index fossil for the Ordovician in Kentucky. A T-Rex is actually a good index fossil, and you would want to say Jurassic, but Paramount has it wrong. It's actually the T-Rex is more dominant in the Cretaceous era, but Cretaceous Park does not sound nearly as cool as Jurassic Park. So I'll have a bone to pick with that, literally, no pun intended, in a few days as we talk about our dinosaurs. And then breaking it down even further is our epochs. And we look at those as areas of land that is not deformed, and scientists can kind of divide them down. So looking at maybe what were some of the erosional features that were there. Whoops, sorry. The original features. So once again, here's another kind of look at our time scale here. So here's our, here's my mouse, there we go. Here's like early Earth, no life. This was in our Precambrian eon, our most furthest out. And I always think of Precambrian meaning no life. And then when we get to our Cambrian period, there's our explosion of life, and life is here all the way throughout. So we're starting at our bottom with our Precambrian, and then it branches off into those three different eras: our Paleozoic, our Mesozoic, and our Cenozoic, and that's where it breaks down even further. So no life, no life, no life, all Precambrian. And then all of a sudden in the Phanerozoic, we get our three eras: Paleozoic, Mesozoic, and our Cenozoic, and then into our periods. So evolution is going to be a part of this class, and especially our discussions that we have in the next couple of days, as we look at how things, organisms, either animals and or plants, have kind of evolved. So I know that can be a touchy subject at some points, but I want you to keep an open mind and think about it in the grand scheme of things. We can actually see an evolution of simple little animals, such as, I'm going to keep bringing up the trilobite. We can see that it has gone extinct, but we do believe that it has evolved into something that looks very similar, which is our horseshoe crab. And so we'll talk about what that actually looks like. There's always lots of discussion that possibly, if you've watched Jurassic Park, you know their big piece of thought process is that dinosaurs evolved into birds. Do we know if that's true or not? No, but we can look at some evolutionary pieces that do significantly kind of link them together, and we'll take a look at that as we move through, and you'll actually get to do a project here on dinosaurs in the next couple of days as well. So evolution is just a geologic change. So meaning that even when we look at the environments that have occurred over the Earth's time period, we can see a progression of changes. And sometimes when the Earth got really hot, we can see an explosion of life, and then all of a sudden the Earth cools down and we see a huge extinction. And then it gradually gets warmer again. We see another explosion of life, and then bam, there's another cooling off period, and it gets we go through another extinction. And so it goes through these like waves of processes. And so fossil records show us species surviving environmental change while others disappear. That is your survival of the fittest right there, that sentence. Fossil record shows species surviving environmental change. Some are going to be more adapted to be a part of the process, while others are not. And so I want to finish here with just talking about the Precambrian era. So the Earth is a great recycling system. We haven't talked just yet about plate tectonics, but we will. And the Earth goes through natural processes where rocks are broken down, recycled, and then spit back up, just kind of like what we talked about in our rock cycle. And so our most earliest rocks are sometimes the most hardest to find because they just don't exist, because they went through the rock cycle process. However, there are portions of the Earth that we can find that is the oldest rock on Earth, and those are called Precambrian rocks. And they are the oldest because there is 0 life forms found in them, 0 fossils. We can find this actually up in Canada. There is a big, long, they call it the shield